Welcome to Luca and Miguel. Enjoy the video.
You start by locking prerequisites: power, cooling, space, and stakeholders. Once power capacity and redundancy are confirmed, size UPS and generator runtime to cover peak kW. Make sure the site meets latency and cooling constraints, and decide rack density targets in kW per rack to guide layout. Next, assemble a cross-functional team, facilities, network, security, procurement, and set a clear budget and timeline. This rapid kickoff keeps design decisions aligned with operational realities and prevents rework later. Once the kickoff is done, translate requirements into detailed drawings and specs. Lay out hot and cold aisles, containment, rack elevations, and cable tray routes so airflow and serviceability are optimized. Simultaneously, design electrical feeders, busways, PDU, breaker schedules, and grounding. Make sure load balancing and redundancy meet N+1 or 2 N targets. Define a network topology with diverse fiber entry, redundant paths, and clear security zones. Verify procurement lead times and coordinate installers so mechanical. You finish by commissioning and documenting everything before handover. Execute power failover, generator start, PDU load transfer, cooling capacity and airflow validation, plus network failover tests, record results and thresholds. Make sure as-built drawings, single-line diagrams, cable labels, and SOPs are complete for operators. If issues arise, isolate using logs and sensor data. Perform a staged rollback to last known good configuration, and swap the suspected component only after correlating events. One key tip: check environmental thresholds first. Many faults trace to
Thanks for watching and please subscribe. It's the best investment you'll ever make.